Okay, now for the last part of this section, what we want to talk about is basically what the graphs of these radical expressions would look like. So let's go ahead and talk about some general radical expressions here. So we're trying to graph functions that are defined by radical expressions. What do we mean by a radical expression? Before we can start graphing them, let's go ahead and see what a radical expression is. It basically is an expression, or an algebraic expression that has radicals in it. Okay, so a algebraic expression that contains radicals. So, for example, you can think about as something like 3 minus square root of x, cube root of x, or maybe something like this, 2x minus 1. Basically, as the definition says, an algebraic expression that contains radicals. What we will do is look at two basic graphs here. We will look at graphs of square root of x and cube root of x. Okay. So square root of x and cube root of x. Now to look at the graph of these functions, we're basically going to use the basic graphing method, which is, find a few points, plot it on your coordinate axis, and then join the points. Okay, so something really simple here. We'll start with the square root of x graph first. Now remember, anytime you're trying to graph a function, you need to find at least 4 or 5 points that you can use to get a good idea of what your graph is going to look like. So what value of x can we use? You can use 0, okay, and y, of course, you will use square root of x to find the value of your y. So if you take 0 as your x value, square root of 0 is of course 0, so that gives you your first point. If you want to use 1 for your x value, square root of 1 will be 1, because if you take 1 to the second power, you still end up with 1 as your answer, so you end up with a point 1, 1. Now I don't want to use 2 for my value of x, because square root of 2 is an irrational number, and it's kind of hard to try and graph it on a number line. Same thing happens with x equals 3. So I'll skip those two numbers and I'll go straight into x equals 4, because 4 is a perfect square. So if I take square root of 4, it gives me 2. Okay, so I have another ordered pair. And how about we go ahead and use another number that is perfect square, which will be 9. Because when I take square root of 9, I get 3. And you can see I have 4 points here that will help me, that will give me a good idea of what the graph should look like. Now again, remember, the reason I skipped 2 and 3, 5, 6, 7, and 8 was because these numbers are not perfect squares, and I just want to deal with whole numbers here to try and graph. If you want to use those numbers, you can. There is no restriction against it. Alright, so let's go ahead and graph this and see what the graph of square root of x will look like. So we go ahead and draw our coordinate plane, mark some points, 1, 2, 4, 5, 6, 7, 8. I need at least one more for my 9. So 1, 3, 5, 7, 9. And then you can see all your y values are positive numbers, so I'm not even going to bother about the negative part. And you have 1, 2, 3, 4, 5. Alright, so let's go ahead and try and graph these points now. So your first point is 0, 0, which will be right here at the origin. The next point is 1, 1. Then you have the point 4, 2, which should be somewhere about here. Okay, if you guys have a graphing paper, go ahead and graph on that. Your graph would look much more accurate. And then your last point was 9, 3. So let's see, 9, 3 would probably be somewhere about here. Once you plot all your points, go ahead and draw a curve through those. And this is your graph of your square root of x function. So you can see this is a curve which is that has positive x and positive y values. There is no graph on the negative side of your coordinate plane. And if you want to go ahead and find your domain and range, you will see in terms of your domain, remember again we talked about domain and range in chapter 7. Your domain is going to be all positive values on the x-axis, because again there is no graph on the negative x-axis, and since your graph starts at 0, you will go ahead and include 0, and you will say your range, your domain is from 0 to positive infinity. If you look at your range, you will notice a similar thing, because on the y-axis again you don't have any graph on the negative side. Your graph is all on the positive side, so again your range starts at 0 and goes all the way through positive infinity. So your range and domain in this case will be the same interval. Okay, so basically that's how you can go ahead and look at the graph of a square root of x function, and we will use the same idea to graph our cube root function here. We'll do the same thing, find a few points using our t-table and then try and graph that. So let's look at cube root of x. Okay, so again, let's see, we can start with 0. Cube root of 0 will be 0. Again, avoid those numbers that will not give you a whole number or an integer as your answer. So try and use the values. Those are perfect cubes that you can use for your x. So 2, 3, 4, 5, 6, 7, none of these numbers will give you a perfect cube, but you can start with 8, because cube root of 8 is 2. Okay, so you can get the point 8, 2. Since this is cube root, you can use negative numbers in your cube, and cube root of negative 8 gives you negative 2. Okay, and if you try and find the next perfect cube, that's actually going to be the number 27. If you take cube root of 27, that gives you 3 as your answer, but 27 is just too large to try and graph on this piece of paper, so we're trying to go and see if we can graph just using these first 3 ordered pairs that we found. Okay, so do the same thing. Go ahead and draw a coordinate plane. Mark your points. So 1, 2, 3, 4, 8. All right, and then on your y-axis, so this is your 1, 3, 5, 7, negative 2, negative 4, negative 6, negative 8. Okay, Once you go ahead and mark all your points on your axis, let's go ahead and start plotting these points. So your first point was 0, 0, which is again at the origin. Your next point is 8, positive 2, so that will be a point somewhere here. And then the other point was negative 8, negative 2, which will be a point on the negative side, something like this. Now if you try to graph these points, your graph will look something of this form. Okay, again, they're going to be curves. And this is what your cube root of x function is going to look like. Now again, if you try to use maybe a graphing calculator, you'll get a better idea of what this graph looks like. But again, this is a pretty neat graph here. Now let's go ahead and look at what our domain and what our range for this function should be. Now as you can see from the graph, in terms of your x-axis, you are going all the way to negative infinity on this side, and you're going to positive infinity on the other side. So we can safely say that your domain is going to be negative infinity to positive infinity, or all real numbers. And for the range part, again, if you think about this, this graph is going to start getting wider as the x values get larger. So on this side, it's going to go up all the way, and on this side it's going to start going down as the x values get larger on the negative side. So in terms of the range also, it's going to cover the whole y-axis. This will go to negative infinity, and that will go to positive infinity. So again, you can say your range is all real numbers, negative infinity to positive infinity. So anytime you're trying to graph a radical expression here, or a radical function, go with this format here of trying to find the tables and then use those points to plot your graph. Alrighty.